as we continue looking at solving these trig equations, finding the angle in our trigonometric equation, we need to remember something that we have not talked about in a while, which are called extraneous solutions. Now, what are extraneous solutions? Any thoughts? What are extraneous solutions? That is a word we have all heard many times already. They don't work. They are extra answers. They are extra answers that do not really work. Now, what do we do to account for those extraneous solutions? Can anybody remember? What do we do to account for them? Matt? Yep, we must check all the answers. All right, so if I'm taking a look at number 6, which is sine of x, subtract cosine of x, is equal to 1. Okay, now, this is a different situation. Can I do any substituting to make sines or cosines match up? No. It's not sine squared. I can't make this 1 minus cosine squared. This is not cosine squared. I can't make that 1 minus sine squared. Sine and cosine give us problems the way that they are when it is raised to the first power. So, one method that we have for dealing with that, first of all, I want to get them on their own sides. I want the sine on one side and the cosine on the other side. So the first thing I'm going to do is I'm going to add the cosine of x to both sides. Get them each on one side of the equation. Okay, so that means the sine of x is equal to 1 plus the cosine of x. Now, we know that we would be able to do some substitutions off my big 8 if what? It was squared, right? Absolutely. If it was squared, I can substitute sine squared then. I can substitute cosine squared then. I've got some things to work with. And we also know that in algebra, a lot of the things that I do are legal as long as what I do on one side of the equation, I do to the other side of the equation. Any thought on what I can do to both sides of this equation? Let's square both sides. Absolutely. We're going to square both sides because I realize that that is going to help me be able to do some substitutions off of my big 8. All right, so sine x times sine x is going to be sine squared of x is equal to, all right, what are you thinking, Lexi, we need to do on the right-hand side? You bet. 1 plus cosine of x squared is going to be the quantity of 1 plus cosine of x times another quantity of 1 plus cosine of x, so we do need to FOIL. So sine squared of x is equal to, first is going to be 1 plus outside cosine x plus inside cosine x plus last cosine times cosine is going to be cosine squared. All right, got to clean that up. So sine squared of x is equal to 1 plus, well, a cosine and a cosine is 2 cosines of x plus cosine squared. All right, looks very good so far. Does anybody have a thought from here? Does anybody have a thought from here? Yep.
Sine squared equals 1 minus cosine.
Absolutely. I know that to solve these situations, I'm a lot better off if they're the same kind. I'm in a lot better situation if they are the same kind. So sine squared is actually 1 minus cosine squared. And in order to solve, I would prefer that it is equal to what? 0. Okay, so let's subtract 1 and let's add cosine squared. Okay, now we got 0 equal to, well, 1 and negative 1 is 0, so they're going to cancel. And I'm going to put them in order. I like them in order. It just works better for me. So a cosine squared and a cosine squared is going to be 2 cosine squared of x plus 2 cosine of x. All right, let's see here. Andy, what are you thinking we would do to solve that one? All right, 2 is the what? Okay, I can factor it out. Is there anything else I can factor out? 2 cosine, absolutely. My GCF is 2 cosine. So I'm going to take 2 cosine of x out in front of a quantity. Tessa, what's going to be left in that quantity? Beautiful. All right. 2 cosine squared divided by 2 cosine is a cosine, plus 2 cosine divided by 2 cosine is 1. All right. Now, Zach, what am I going to do to solve that? If the two quantities multiply to 0, what is the only way for them to multiply to get an answer of 0? Okay. Somebody help them out? Yeah, absolutely. If these two groups multiply to get an answer of 0, that means one of them has to be 0. The only way to multiply to get an answer of 0 is if one of the pieces is actually 0. 7 times 0 is 0. 0 times 5 is 0. One of the groups has to be equal to 0. So that means that 2 cosine of x has to be equal to 0, or the cosine of x plus 1 has to be equal to 0. All right, 2 cosine of x is equal to 0. Megan, what am I going to do to start getting my angle? Divide by 2. So the cosine of x is equal to 0 divided by 2 is 0. All right, Megan, where do I go to start looking for an angle, or what do I do to find an angle that has a cosine of 0? What? The unit circle. Very nice. So first of all, to get the angle, I use what? Inverse cosine. Absolutely. I'm going to take the inverse cosine, and like Megan said, to find that angle of x, I'm going to use my unit circle. So I'm looking at my unit circle. I have the points here, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. All right, if I'm looking for an angle that has a cosine of 0, which value am I focusing on? The x value. Absolutely. Remember that my x value is always the cosine of my angle, and the y value is always the sine of my angle. All right, Brody, which angles have a cosine of 0?
90 and 270.
All right, so I've got my 0 here at 90. I've got my 0 here at 270. I don't really like 90 and 270. What is 90? Pi over 2. Remember, we're writing these all in radians. And what is 270? 3 pi over 2. Okay, remember, we're always keeping our answers in radians. It's fine to think of it in degrees, but then make sure that we write it down in radians. So my angles are pi over 2 and 3 pi over 2. All right, are we okay with that? Okay, now over here, I have the cosine of x plus 1 is equal to 0. All right, Samantha B, what do I do? All right, we're going to subtract 1. So the cosine of my angle x is equal to negative 1. To find the angle, we know that we do the inverse cosine. So what is an angle that has a cosine of negative 1? You bet. All right, once again, I'm focusing on that unit circle. And right now, my x value of negative 1 at 180, which is pi. Okay, now we had a conversation about extraneous solutions. I need to do the checks. Okay, little bit of flexibility in the way that we do these checks. I want to see somewhere on your paper that you did these checks. Okay, I need to see somewhere on your paper that you did these checks. Now, what equation am I using when I do these checks? The absolute original equation, which was the sine of x, subtract the cosine of x, better give me an answer of 1. Now, I have 3 possible answers. I have an answer of x is pi over 2. I have an answer of x is 3 pi over 2, and an answer of x is pi. Okay, now, what I want to see, because yes, I understand that the calculator is an absolutely great application for this. Make sure your calculator's in radians. I want the sine of pi over 2, subtract the cosine of pi over 2. What do you get when you plug in the sine of pi over 2, subtract the cosine of pi over 2? 1? All right, so 1 equals 1. Everybody's happy with that. All right, let's try the next one. 3 pi over 2, so we got the sine of 3 pi over 2, subtract the cosine of 3 pi over 2, And what do we get for the sine of 3 pi over 2? Subtract the cosine of 3 pi over 2. What do you get for the sine of 3 pi over 2? Subtract the cosine of 3 pi over 2. What? -1. Tessa's throwing out there she got a -1. Agree or disagree? Agree. So -1 equals 1? No. So 3 pi over 2 is not a solution. That is extraneous. It's an extra answer that I get because I squared both sides. All right. Then we got pi. Let's take the sine of pi, subtract the cosine of pi. What do we get? 1. Everybody's happy with that. All right. So that means I really have two solutions. I have x is equal to pi over 2 and x is equal to pi. Any questions with that? The last type of problem I didn't get a chance to talk to you about yesterday, when you're forced to square both sides. When we have a sine to a single power and a cosine to a single power, this is one method that really helps us out. Any questions with that? Yes?
Do you have to like go back over our homework and check it out?
Give me 1 second and I will comment on that. Any questions on this problem? Or in general about how to solve? Okay.